ಕೃಷ್ಣ ಎಲ್ಲೋ ಇವನಲ್ಲಿ ದೊಡ್ಡ ಕಡಿಮೆ ಇಡು ಇಲ್ಲ ಆಫ್ ಮಾಡಿ ನನಗೆ ಬೇಡ ರೈಟ್ what we were discussing the last class, why there is a less strength? Internals. I will take class tomorrow also. Even if you don't come, I don't care. Okay? And tomorrow I will start a new. Right. Yeah, what we discussed in the last class? Yep. ಕಡಿಮೆ ಮಾಡು ಫ್ಯಾನ್ ಇದನ್ನ ಎರಡು ಕಡಿಮೆ ಮಾಡು ಲೈಕ್ is there any doubt in that? Have you understood that J and B instruction will take 2 machine cycle, whereas one count in timer will take 1 machine cycle? Is that concept is clear? Is that concept is clear? The fundamental structure of the program remains same. Timer program remains same, right? What do you like? What is right? And what is important right now is what is the maximum count in mode 1, mode 0, mode 2 and mode 3? What is the maximum possible count value in mode 0? Mode 0 is 13-bit mode. 1 FF in decimal. 1 FF in decimal. What is the value of 1 FF in decimal? One. As count starts from 00002 1 FF, what I do? What is the actual count value? Total number of counts will be how much? 8192 plus 1. 8192. This is the maximum count value in mode 0. Maximum count value in mode 0 is this. Similarly, mode 1. Mode 1 is 16-bit mode. What is the maximum value? FF, that is 65,535 plus 1. That is 65,536. Similarly, 8-bit, that is FF, that is 255 plus 1, 256. Mode 4, sorry, what is that? Mode 3, same thing. What is the same thing? What is the difference? We'll discuss later. Count as if it is concerned, it is also 8-bit. Mode 3 is also 8-bit. Mode 2 is also 8-bit. What is the difference? Mode? Split timer. But basically they are 8-bit. So what is this? Maximum count in each of these states. Now we'll keep connecting this. You should be careful. First, at every point you should have the clarity. Now we'll take this count and then we'll do the next calculation. In the again, right? So any doubt in this? All of you are clear? All of you are clear? It is simple. 13-bit mode, 1 FF is a maximum number. Decimal value is this. Total plus 1 is because it starts from 000. 8198 is the maximum possible count. From this, if I tell you what will be the, if I tell you the frequency of the clock is 12 megahertz. 12 megahertz. What will be the maximum time delay generated by this one, mode 0? I tell you the given clock frequency is, am I audible to all? Kamath, you can hear me? Right. If I tell you the given clock frequency is 12 megahertz, what is the maximum time delay generated by 13-bit count? How do you say that? F clock is this. What is the clock given to the timer? Timer clock is what? Timer clock is what? Timer clock is 1 megahertz because it is always F clock divided by 12, and this divided by 12 is independent of machine cycles. Machine cycle will change for the different 8051 controllers, but this 12 remains same. So this is not the machine cycle 12. Fortunately, your 8051 architecture study, is that clear? Right. This 12 will give us what? 1 megahertz. If the frequency of the timer clock is 1 megahertz, what will be the time duration? For one count. 1 microsecond. For one count it is taking 1 second. For this one is a maximum delay microseconds. You are understanding this? The maximum value is this. So it can generate so much of microsecond delay if the frequency is 12 megahertz. Input frequency is 12 megahertz. Right. Now, so having said that, now what we do is we will generate okay. What we do now is, like, we will try to generate time delay of 5 milliseconds using any one mode. Any one mode. Let's say select mode 1. Mode 1. Generate a time delay of 5 milliseconds. How do I generate a time delay of 5 milliseconds? This is all, whatever we are discussing today is all about like time delay calculation. Using timers, how can I calculate the total time delay? Right? So how do we generate 5 millisecond delay using timers? Let us say using mode 1. How do we start? How do we calculate it? Let us say using mode 1 and 5 milliseconds when XTAL is 11.0592 megahertz. This is a given clock frequency for a microcontroller. Now how do we generate it? First step, what should be the first step? I know that clock frequency is 11.0592 megahertz. Now I should calculate the frequency for timer clock. Timer clock frequency. This is divided by 12 is what? 11.2 into 10 raised to 6 divided by 12 is what? Quickly, anybody? 921600. Right? This is hertz. 921600 is hertz. Right? So what is the time taken by each timer count? 1 by divided by this T clock, 0.85 microsecond. This is time taken by one count. Time taken by one count. Now what should I do? If I say like this, what is that? 1.085 microseconds. That's all. That's what is a cycle. 5 milliseconds per how much? This is the thing that you do in the basic thing. So 5 milliseconds divided by 1.085 microseconds. What is the answer? 5 milliseconds divided by 1.085 microseconds. 4608.29 seconds. This is all in seconds, so it will be. No, hold on. 4608 is the total number of counts that we wanted. Right? Seconds will cancel, so this will be the count. Now, the problem is you have only up counter. You have only up counter. The maximum possible value in this is what? 65,536 minus 4608.29. What is the answer? 60,928. This is in decimal. Tell me the hexadecimal value of this. Chetan, Bega. Channa, we don't have a calculator. Kamath has not slept yesterday. Double E, 00. This is the count value. What is the count value? This represents TH0. This represents TL0. You're understanding? How to calculate the count value when the given question is like this? Right? $4,000. 609th count. Yeah, that is why we have considered here 65,536. This will count full 00 to FF. Next it will start 00, right? What you are saying? It should be 4609. Yeah, once it goes from FF to 00, then like TF will be 1. So what you are saying, it has to be less than 1, less than this value. I don't think so, yeah. We'll validate in the lab and check it properly. But right now this is the calculation. Let's see, whatever the Hasib is saying, we'll validate this in the lab. No, though we will not get this value, we'll take small value and see. Any doubt in this? Now if the same thing, is it possible? Let's see. Is it possible using mode 2? Faraz, have you understood what I am saying? Can you calculate, is it possible using mode 2 first? Can you tell me that? Possible? How many times? How many times? What is the value? ಅವನ ಹತ್ರ ಇದೆ ಹೇಳು ಅವನಿಗೆ. 18 times. 250. Yeah. So if you consider now 4608 divided by 20 is what? Let's be very clear on that number. 230. 230.4. Let's say 230 approximately. Okay, listen to this. Till here, why I am saying exactly coming here, till here the calculation remains same. Whether you use mode 1 or mode 2, it does not matter. What is important here is the given count will not fix in 256 FF value. So what we do, we'll divide it by 20. So the count value is 230 now. Now what I do, this 20, I will put it in R5 and use it as a DJ 20 times in 30. 230 is in hexadecimal is what? Huh? A6, E6. No. Hold on. You should do this. 256 minus 230 is what? Shall I rub this part? Shall I rub this part? Ah. 26 in decimal. Hexadecimal value of 26. 1A. 1A is a value which will be stored in TH0. You are understanding this? 1A is a value which will be stored in TH0, which will be copied to TL0. We'll see that now. Now we'll see that what is timer mode 2. Have you understood this? This calculation. Timer loop should repeat for 20 if you are using mode 2. Guys, is it clear? Hello? Listen to me one more time. Whatever the time delay is required, first thing you should look at it is clock frequency. If they have not given the clock frequency, you have to assume this. You have to assume this, right? Assume the clock frequency is this. Then you should go ahead with the calculation. Is it clear? If they have given you the clock at 1.085, sometimes they will give you 22 megahertz here. If the given clock frequency is 22 megahertz, then what will be this value? First thing is this one. Am I clear with the question? Then you should go with this calculation. This calculation, if they have told you in specifically timer mode 2, then you try with timer mode 2. If they have not given you anything, timer mode 1 is the best and easiest value. Right? So calculate this, you will get a count. What is the highest value? Why is that you should subtract by highest value? Because your count is up counter. From the given value, it will count to the maximum value. From the given value, it will count to the maximum value. Then your count will be 230. If you start at 1A and reach FF, then your count value is 230. Is it clear? Because it is only up counter, you have to subtract and get a value. Now, depending on the timer modes, you have to put this value in TS0 or TL0 or both of this, you should decide. No. Chetan has a doubt? Chetan, right? Did I send you a mail? Did I send you a mail? You got my mail? What mail is that? Huh? You didn't get? Didn't see? From Saturday, I have sent you a mail on Saturday somewhere. You are, why are you saying it to him? Like he checks your mail. Chetan, right? What is your mail ID? Chetan? Yadav, correct, right? Chetan Yadav, I have sent you the mail. You told me on the self-study time, your project is to display that, right? You wanted a 7-segment display, larger display. I went to Domino's Pizza, and then like they display there your order number. That is 7-segment display. That they have the serial communication connected with that. You saw that mail. What I said in that mail? What did I say in that mail? Check who supplies that. Contact me back. You got what I said in that mail? What happened? Today you are going to SP Road. Right. Second, let me know. One more thing. I don't want you to go today. Today, nothing doing. Concentrate on the test. After the exam, Saturday, you go to SP Road. Who else is there in your team? Oh, your team. Only your mail quickly and then I send it to you. I have not sent it to them. Okay? Right. Any number which is, I want this count to be less than 256. Anything is fine. Yeah. You started from 256 and started from 0. That is also fine. Guys, here, what is Faraz's doubt is, if I divide it by 256, so what is the value that I will get? 18. 18 is the value that I will get. That means I have to divide it by 18. Divided by 18, here it is 256 as a value. So R5 is value, 256 minus 256, 0, 0. The T at 0 will start from 0, 0, not 1 E. Right? That is also right. But no difference in the time delay calculation. It happens 20 times, or like this one, it will be same almost. Yeah? Anything above 18 is right. Below 18 is wrong. You're getting my point? Anything above 18. Anything above 18. We'll come to that. We'll come to that. Like what exactly mode 2 does, we'll discuss. 5 milliseconds. It will start from 0, 0 to FF. What will be the time delay if the given is this? Into 256. 1.085 microsecond into 256. That is a minimum time delay generated. Multiply by 18. Should be value which is around 5 milliseconds. You will not get exact time delay. Yeah, 18 times it will wait. DJ and Z. Yeah. DJ and Z R5 you use. Rotate it for 18 times. If you ask me, sir, is it exactly 5 milliseconds? No. Because you have considered, Asif, should I have to teach or you have to teach? You want to teach? Come here. Don't talk. Everybody should give an attention towards that. However simple, silly question is that. Right. The whole point is you are calculating only timer value for 5 milliseconds. There is no calculation for J and B. There is no calculation for TS, set bit TR0. Those instructions will also come in loop. We have not calculated the value for them. So it will not be exactly 5 milliseconds. It will be slightly plus or minus this thing. If you want exact calculation, you should write a program check. You are understanding my point? It will not be exactly 5 millisecond value. With this timer value is 5 milliseconds. Whole program delay will not be 5 milliseconds. Right? We'll write a program and then see now. Color of this procedure is standard to calculate the time. Okay, I have one more twist in this. One more twist. Instead of 5 milliseconds of 1 kilohertz, square wave of 1 kilohertz. Now square wave of 1 kilohertz, what will be the time delay calculation that you have to do? 0.5 millisecond. 0.5 millisecond. 1 kilohertz is 1 millisecond is the total delay of the cycle. Positive half cycle, negative half cycle. So it has to be divided. 1 millisecond divided by 2 is 0.5 millisecond. So same calculation, you have to include 0.5 millisecond wherever you have 5 millisecond now. Is it clear? And please keep this in mind. If they change this, it will be very crucial to calculate this. Don't just rush and use 1.085 everywhere. Observe, read the question properly on program. Right, is there any variant? I will check and then we will go ahead with that. Yeah, 2. Before going to mode 2. Mode 2 is this XTAL divided by 12 XTAL divided by 12, then it will be given to TL0, this thing, right? They will be given to an AND gate which has TR0 as a control, and then this will be given to TL0. This TL0 will set TF0. This TF0, when it is going to set that, it will reload the value from TH0. Or auto reload. Auto reload mode. This is auto reload mode. That is why mode 2 auto reload mode. Here only you write. Okay? Clear? Right. Is it right? So it is very similar to mode 1. In mode 1 we had here TH0, TL0 connected to TF0. We don't have this part. It just used to count this. Depending on the signal here, it starts counting here. Now if you give a signal, only TL0 will start counting. Once it reaches 0, it will take the value from TH0. Whatever the value you have. For example, 1A, if you have in 1A is in TH0, then 1A will, you're understanding? So always count is from 1A to FF. 1A to FF, 1A to FF, 1A to FF till you stop it. How many cycles there? 20 cycles. 20 times 1A to A, 1A to FF will do using auto reload mode. Now we'll try to write a program for this. Okay? Bye. Okay, what I do is I will take that general program that we discussed in the first class of the timer. When we started the timer, ORG 00H. Okay, I will try to write it small so that I can fit it in one. And 01H. Huh? That is 10 will become timer 1. I'm just writing the program that X FF. Move TL0 is 0x FE. Then, no, just first program I am writing. First general program for timer mode 1. Mode 1, whatever I have written, I am writing down. TL0 is FE. Then what I did, load these things and then like call the CPL. CPL port 1.5. Is this font is visible? Is this visible? A call delay. Then S jump here, where we gave here, yeah, here has to be here, right? Then here, like what we did, delay, set bit TR0, TF0, comma, dollar. We are jumping back here till this becomes 1. Next, CLR, TR0, CLR, TF0, then return. Correct? Did I wrote it correctly? The program is right exactly the way we have written it previously. Okay. Huh? Plus 1 in that case. Total count will be 65,536, not 535. Huh? In the register?
Now suppose you want to count from 0 to 65535, you count to 65536 from the register.
Correct, yeah.
So when you want,
that is what we'll discuss. Right. Guys, is that visible properly? This is a program that we have discussed in the previous classes for timers. Right. Now, before doing any change to this, I want you to write a program in C. Same program in C. Right? Please, if you are not written in this copy, please write it. reg51.h, then what I have to do, which is this, S bit P15 is equal to port 1, 5th pin, wide, delay, wide. I will write the function first here itself so that I will avoid making a prototype here and then defining a function here. Chetan? Yeah. So what I do in here, in delay function, whatever I have written here, I will write it here. What is this? Set bit TR0. Set bit, sorry. TR0 equal to 1. C program, right? TR0 equal to 1. TF double equal to 0. Create a loop where there is nothing. It does not do anything here till TF is 0. Once TF is 1, it will come out of this loop. Is it clear? It is same as JNB instruction. You can also write this as like this in C. Okay. TR0 equal to 0. TF0 equal to 0. Then come out of this loop. Just here. This is called as subroutine in assembly. This is called as function in C. The conceptual idea is same. Whatever I have written here, I have written here. Wide main, wide main, wide, wide main, wide. Neither I will reply anything nor I will take anything in it. Next, in this what I have to do? This part of the program. First thing is what? Tmod equal to 0 1. No. Okay. Next, TH 0 equal to 0x FF. TL 0 equal to 0x FE. Right? Next, what should I do? Okay. Hold on. This should be in while loop. This is a while one loop. T mod is outside this while one. I have to write while one loop before this. While one, TH0 equal to 0x FF, TL0 equal to 0x FE. Next, this one. Somehow I have to come here. 5 equal to not of P1.5. Next, DLAY, delay, caller delay. Huh? Okay. This P15 is because of this S bit. Where is S bit? S bit because of this. I have converted it to C. Same program in assembly I have converted it to C. Here S jump here will be while one loop here. In while one I have to repeat all these things, right? The unconditional jump is while one. Is there any doubt? Is there any doubt in this? Is it clear? Right. Now this program has been written in mode 1 to count a value from TFE, right? And we have analyzed it. Now if you ask me, can we analyze the same in C? No, not possible. You cannot count machine cycle in this because it depends on compiler. Only when you fix on your compiler, only when you fix to a compiler, you can see disassembly window. In the disassembly window, by seeing there, you can calculate a number of machine cycles taken by whole program. You're understanding what I'm saying, right? Then only you can say, okay, this program will take so many machines because it is compiler dependent. That we have discussed, right? We have given you the point also, right? Now this is what we have done. Previously, we have calculated some time delay for 5 milliseconds. 5 milliseconds. What is the T0 value? What is the T0 value for 5 milliseconds if I want a delay of EE00? This is the case, I have to change this program here, EE00. Same thing. Here, it is EE00. Huh? Huh? T0? We are using TH0, TL0. T0, I don't think it is defined directly in register 51. We should see that. If it is defined, you can use. Because T0, TL0 are standard registers in SFR. T0 is a combination of these two registers. I don't think it will be defined. If it is, you have to check. If it is defined, you can use that. Guys, did you got this solution? Same thing. How do 5 millisecond delay generation program is same thing as like this. Right? Now, very important point. This is in mode 1. Now using mode 2. Using mode 2, we have changed this program little bit. How is that? What is that? We said R5, we'll put 18. Okay, 18. Then like TH0 is what value? It should start from 00, go till 256 count. So it is this one. for your ease of calculation or to convince you the mode 2 properly, I will take it 20. It can be 18, nothing wrong, correct? 20. Then like what will be the value here? 1A. Right? Now I will do the same thing. Guys, observe now. What what is the change that I am doing? First thing, what should I do? T mod is what? T mod is what? As it is mode 2, it is 02 here. First change. First change is here. Next, second change. TL0 will not be there. TL0 doesn't. TL0 will be there. Okay, initially it has to be. TH0 is what? 1A. TL0 initially you load with 1A. 1A. Okay? Let's see to this. Please don't write. Please see here. Now what is the next thing I have to do? That is also important. Move R5, comma hash 20, right? No, we'll do one thing. 20 is the 1F. 14, sure. 0x14. Right? After that we have CPL delay, then this here, set bit, this will be correct, CLR TF0. Now, in here what should I write? DJ and Z before return, comma, delay. Then RET. This will jump back here till what time? 20 times. 20 times. Okay, once it finishes 20 times, then returns back to sjump here. Now sjump here has to be here or here. Guys, listen to this very carefully. This is the only small change that you need to do. Program. Mode 2 program. Whatever the value of TH0 is there, it will not change. It is fixed, freeze. Only value of TL0 will change. As it goes from 1A to FF and rolls back to 00, TH0 will give a value according to the previous diagram that we have discussed, mode 2 diagram that we have discussed. TH0 value will be loaded to TL0 and then it starts from there. So here has to be pointing to R5. R5 has become 0 here. DJ and Z, right? We have decremented that and made become 0. Now once we come back here, jump here, now I have to load the R5 again. Load the R5 again. Then this delay and then the complement it, then call a delay. In a delay what I am doing? Timer start and stop I am doing 18 times. Sorry, what is that? 20 times in this case. 20 times. Once 20 times is over, I will come back here. Is it clear? No, TR0 is stopping the timer. Once it becomes 00, it will stop the timer. Then like, to clear the flag, DJ and Z R5, decrement it, then start a timer. When you start a timer, TL0 will get a value from TH0. Then again it starts from that value. You are getting is this one? Is it? Any other doubt? Guys, very important thing is the same program structure. You should know where to give the value here. This is second change. This is second change. This move R5 is required only if the count value is more than 256. If it is below that, directly this only. Move R5 is required. Why? Because count value we had as 4608. Correct, right? 4608 was the count. Then you don't require R5. Then programs becomes exactly similar to the original program. You are understanding it, right? You are getting it, right? If the count value is just 183 or something like that within 256, This will not be there, this will not be there. So it is very similar to the previous program. What is the change? Mode is a change, infinite loop is a change, while one is a change, rising. Clear, right? That is what is the structure. If I set it in mode 2, that is what is the structure. It is connected like that. Hello. What if you remove? Yelli? Move TH0 ಗೆ ಇದು ಬೇಕಲ್ವೋ ಬಿಡುತ್ತೆ ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ವ್ಯಾಲ್ಯೂ 1a ಅಂದ್ರೆ ಒಂದು ಹಿಯರ್ ನಾ ಇಲ್ಲಿ ಕಳಿಸ್ತೀಯಾ ಇಲ್ಲಿ TL0 ಗ it is not required anta as it is in mode 2 setting it again is not required because it happens by itself. You don't need to do it. Neen mado whatever you want to do it, right? The same thing is done by controller. You are saying you want to move TL0 this one. Yes, you can move this in mode 1. From where it happens from TH1. Is it clear? Right. Any question? Any question? Guys, is there any question? Same thing you can write it in here. Write it in here. How will you write DJ and Z in here? For loop. You can use for loop. Repeat that while one. Where is DJ and Z in this? Here. Like you should write a for loop and repeat this for 20 times. For 20 times. This part of the program. Then it should come out. Can you write that part? For loop will be here. For I equal to, okay, int I equal to 20, I minus, what is that? Int I, okay, I equal to 0, less than 20, I plus. Okay, once it overs, it should come out of this. See, okay, I have borrowed from Parag. Once it overflows, it comes to this one. That means like once I becomes less 20, then it comes out of this loop and comes back to the delay here, and this delay repeats this thing again. In this again, this value TH0, TL0 can be pushed out of the while loop. This, when I say pushed out of the while, auto reload mode. Or appreciate only if you know it is a mode 2 which is auto reload mode. Right? Now if like the Harshit is asking, if I write it what happens? Nothing will happen. It will be like that only. Any doubt? Right? Now we'll slightly go, next we'll go to mode 3. What happens in mode 3? Please write it down. In mode 3. Mode 3, split timer mode. Split timer mode. Mode 3 in bracket, split timer mode. T0 refers to TL0. T0 refers to TL0. T1 refers to TF0. T0 refers to TL0. T1 refers to TH0. Guys, listen it carefully. This carefully. T0 refers to TL0. T1 refers to TH0. In such a case, guys, listen. There is no meaning of TR1 to the timer 1. Or there is a meaning of TR1 to TH0. TR1 equal to 1. If you make, where is TR1 equal to 1? TR1 equal to 1, then TH0 will start. If you say TR0 equal to 1, TL0 will start. Independently, these two are split timers. Inside itself, guys, listen to this once again. timer 0 has TH0, TL0. Timer 0 has TH0, TL0. Now they will become independent and TL0 will become T0, TH0 will become T1. Is that clear? This is split timer mode. Mode 3 is like this only. So whatever the flags associated with the timer 1, timer 0, TR0, TR1, TR0 will get referred to TL0 now, TH0, TF0, timer overflow flag 0, that get refers to TL0, TF1 refers to TH1. Is that clear? So please write in bracket. Huh? We'll come to that. Please write in bracket. Please write in bracket. You have said what is that you have written? T1 refers to TL0 in bracket. In bracket TR0 comma TF0. In bracket TR0 comma TF0. Next one. When I say T1 refers to TH and TF1. Is that clear? Is this clear? In that, what is the change in that? Mode 3 is mode 3 here. Anyway, there is no timer 1 meaning, only this one. This exactly what he was saying, while 1 within this it has to come within 1. That's all the change. You are understanding? Only mode value you change it to 3. These two values which I said in mode 2 has to be out of 1. Is it clear? Right? Now, what is that we have written? So associated flags TR0, TF0 will refers to that thing that we finished. Next one, next line you write. Hence, real timer 1 will not be associated with. Hence, real timer 1 will not be associated with any flags. Will not be associated with timer 1 will not be associated with any flags in this mode.